Hello everyone. Here is a quick preview of the upcoming topics for the rest of this semester. We'll be spending the next three lectures on the topic of web. Following that, we'll be spending 1 week covering the topic of databases. It is likely that you will encounter some form of a database as part of your future job. This is considered the most helpful topic covered as part of this course. After databases, we'll be spending 4 lectures covering the important topic of plotting. If you want to convince someone that your data analysis is correct, showing them a well done plot would be the straightforward way. Finally, we'll be spending 1 lecture on the topic of randomness, and we'll wrap up this course for this semester. Let me outline the learning objectives for today's lecture. We are going to get today's lecture started by learning various basic terminologies associated with networking. Then we are going to learn about a protocol called HTTP. Following that, we are going to learn about a module called requests, which will enable us to download data from the internet. Let me get started by motivating the need for covering the topic of internet in a data science programming course. There are tons of data sets on the internet available for you to download, process, and analyze. Let me give you 3 examples. The first example that I want to provide is Open Payments dataset. You might not know this. Drug companies can offer incentives to doctors in order to sell their drug products. This is sort of like a quid pro quo. Good thing is that all of this information must be documented and made publicly available. The Open Payments dataset enables you to access this publicly available information. The second example that I want to provide is from Humanities. You'll be able to download, process, and analyze 57,000 free ebooks from Project Gutenberg. The third example which I want to provide is city level data sets. A lot of cities within United States release information publicly. A few years back, City of Madison passed the Open Data Ordinance, which enables the city to release majority of its information in a public manner. The only information withheld by the city has privacy based concerns. If you go to the City of Madison website, you'll be able to download trees dataset which provides information about various trees managed by the City of Madison. You'll also be able to download the accidents dataset which indicates the location within the city limits where accidents occur. You can download and analyze bus routes dataset in order to figure out who rides the bus and when they ride the bus. Analyzing the bus routes dataset will enable you to share meaningful information with the city for improvising bus routes by taking into consideration various people needs. You can check out other examples of datasets if you click on this course website link. Why not just download all of these data sets manually, like how we have been downloading data sets for CS220 projects? Why should we learn how to write a program to automatically download the data set? Let me give you a twofold motivation for that. The first motivation is that sometimes there might be too much data to download. An example of that would be Project Gutenberg. Imagine having to download 57,000 books manually. That will take weeks of your effort. Instead, if you can write a Python program to automatically download this dataset, you can access the dataset in a matter of few hours. The second motivation is that data doesn't always come in the form of files. An example of that would be the cool OpenStreetMap dataset, which provides information like bike paths, railroads, roadways, and so on. You cannot download the dataset from OpenStreetMap in the form of files. Instead of that, you need to use what are called as API calls. API calls are very similar to function calls. Instead of having a function within your laptop program, imagine having the function implemented on a remote server, and you'll be making what are called as remote procedure calls or RPC in order to get data set from the remote server, which is going to be returned when you make the API calls. You can specify a rectangle in the form of latitude and longitude boundaries in order to download interesting data sets. For example, you'll be able to download all the bike paths within the city of Madison limits. Let's learn about basic terminology associated with networking. A very basic computer network would connect two different computers. One of the computers is going to send a request for some data to the remote computer. Your request for data does not always have to be about downloading data from the remote computer. You can upload data using requests as well. Uploading data is what is enabling me to deliver this lecture content to you. I'll be sending a request to the YouTube server to upload my lecture video. The request will have binary format, so you're only going to see ones and zeros. The remote computer is going to receive the request and it is going to respond to your request with some data, which is again going to have binary format. The computer from which you send the request or the program application within the computer which is sending the request can be called as the client. The program application running on the remote computer which is sending the response or the remote computer which is sending the response can be called as a server. Here is a challenge. Internet needs to connect millions of computers. How do we indicate which machine our request should get sent to? That's going to be very similar to how the postal mailing system works. If you want to send a postal letter to one of your friends, you're going to look up their address and write their address on an envelope. Then you can trust the postal service to get the letter to your friend at that correct mailing address. In a similar way, computers have what are called as IP addresses. IP stands for Internet Protocol. Here is an example of an IPv4 address. IPv4 stands for IP version 4. Once you have IP address of the remote machine, you'll be able to send a request to that particular IP address. The challenge is human beings find it very difficult to remember numbers. Imagine having to type an IP address every time you search for something in Google. That's why we have what are called as domain names. It is easier for human beings to remember alphabets which form these strings. It's easy for you to type www.google.com, www.google.com. Here is an example of a domain name. Every time you access the course website, you're accessing my domain, which is www.mshyamkumar.com. DNS servers, or otherwise called as domain name servers, enable us to look up the IP address corresponding to a specific domain name. Once you look up the IP address, you'll be able to send the request to the remote computer. Now you no longer have to remember IP addresses. I have couple of program applications running within my client computer. One of those is Chrome, another is a Python program. On my remote computer, which is the server, there are three applications running. Couple of those are Python programs. The third one is Nginx application, which is becoming a famous web server application. How do we identify which particular application program the request message should get sent to? That's going to be very similar to what we call as apartment numbers in the postal mailing system. Let's say that you live in an apartment building. All of the folks living in the same apartment building will share the same mailing address. Apartment number is what differentiates your apartment from some other neighboring apartment. In a similar way, we are going to have what are called as port numbers for application programs running within computers. Here are example port numbers 8080, 5000, and 80. You'll be specifying the IP address, then a colon, followed by which you're going to mention port numbers. The default port numbers are going to be 80 for HTTP and 443 for HTTPS. That's why you don't specify port numbers that often when you send a request to a remote computer. Let's talk about what request and response messages contain. Well, that depends on what sort of application we are talking about in terms of connectivity between two remote computers. You'll have various applications like video chat, browsing, and so on. For the purpose of this course, we are only going to consider simple web application which will have simple request and response format. I'll wrap up this lecture video here. In the next lecture video, we are going to learn about the HTTP protocol, which is going to enable us to transfer content from one computer to another computer via the internet.